Hello, I'm Bill Serban, Director of the Center for Advancing Teaching and Learning at the University of Wisconsin-La Crosse. This presentation is about learning from examples. Teachers use examples routinely to illustrate an idea, crystallize an abstract concept, or help students grasp a complex procedure. If used appropriately, examples can play a significant role in student learning. There are many different types of examples: anecdotes, demonstrations, images, or activities that represent a concept or procedure can be examples. I want to focus on one type of example called worked examples, or worked out examples. A worked example consists of a specific problem statement and then a detailed explanation of the solution. Worked examples are a common feature in subjects where problem solving is a prominent goal, such as mathematics, sciences, and other technical subjects. But they can also be used in non-technical subject areas as well. We have all experienced worked out examples as students. In a typical scenario, a teacher introduces a new concept or type of problem by showing and explaining how to solve it, that is, by providing a worked out example. Students may ask questions, the teacher may provide another worked example, and so forth. After a few worked examples, the teacher asks students to solve similar problems in class or for homework. Worked examples are especially interesting because they are widely used, but their true potential is rarely tapped. Research shows that in the initial phases of learning something new, students learn better and faster by studying worked examples of problems than by solving problems on their own. This table shows the results of a study in a geometry class that compared students who learned by solving problems with those who learned by studying worked examples. In the learning phase, students were taught how to solve geometry problems. The learn by doing students were then given a set of problems to solve. If they couldn't solve them, they were shown in worked examples. The learn by example students were given worked out solutions of the same problems and told to study them. Note that in the learning phase, students who studied worked examples took much less time to study each problem and rated the problems as easier than students who solved the problems on their own. At the end of the learning phase, students took a transfer test to determine how much they had learned. The results show striking differences between the two groups. The students who studied worked examples solved more than twice as many problems as the students who had solved problems on their own. The worked examples research goes against a deeply held belief that students will learn to solve problems best by actually solving a lot of problems. To the contrary, students learn best by studying the solutions to the problems. I will have more to say about this in a minute, but first, let's examine how and why studying worked examples facilitates student learning. It's important to recognize that when students are unfamiliar with a topic, a new problem in that area is very complex. Perhaps this sounds obvious, but to the novice, many different aspects of new problems are novel to them. The difficulty is that our working memories are limited, and we're not able to juggle or process a lot of new information at the same time. We experience cognitive overload. So if we are given a new unfamiliar problem to solve, we may not be able to handle, coordinate, and maintain all the novel pieces of information or procedures needed to solve it. We may proceed by fits and starts, make errors, or simply get stuck. Now imagine that instead of working the solution to the new problem, you're given an elaborate explanation of how to solve it. Instead of having to generate all the information yourself, you can study the solution, go back and forth between steps, and examine how the parts are related to one another. The worked solution serves as scaffolding or support as you try to understand different parts of the solution. In standard practice, teachers do show students how to work problems, and texts provide worked examples. But there are two common shortcomings. First, many worked examples are inadequate. They tend to show steps, but do not explain the reasoning behind the steps. Research shows that elaborate explanations are better than short ones. Second, many students may need a lot more time with worked examples to become familiar with the concepts and solutions. Looking at one or two worked examples may not be enough to familiarize novice students with new ideas and procedures in the problems. Consequently, their initial efforts to solve problems are more effortful, slow-going, and error-prone due to cognitive overload, that is, trying to handle too much new information at one time. Now back to the idea that worked examples can help novices get a better start than solving a lot of problems on their own. Worked examples are very important and effective in the initial phases of learning a new topic, but they are not effective after students have learned the concepts and procedures. There is a point of diminishing returns, and studying worked examples can be detrimental after students have learned the concepts and procedures. At that point, students also need to solve problems on their own to be able to apply the concepts and use procedures fluently. Researchers recommend that students start a new topic with worked examples or a combination of worked examples with full problems that they solve on their own. As students develop a grasp of the concepts and procedures, they can transition to more practice with solving problems. There's a more basic consideration about using worked examples. What do students do when they study examples? Studying examples will do little good if students simply try to remember the solution or gloss over the explanations. Good problem solvers tend to do a lot of self-explanation as they study examples. Poor problem solvers do not. This suggests that teachers can improve the effectiveness of worked examples by using questions to prompt self-explanation during study. This can help guide weaker problem solvers to attend to key features of problems. Prompts can be as simple as inserting questions like, "Stop for a moment and explain the principle behind step D in the example," or "Explain how parts 2 and 3 are related." Conventional wisdom tells us that solving a lot of problems is the best way to develop one's knowledge, but research tells us something different. To become knowledgeable and skilled, students need to spend more time studying the concepts and procedures in the initial phase of learning, and then start to solve problems on their own. Worked examples are key to this initial understanding. There is an extensive research literature on using worked examples to enhance learning. For more information, see these references.